Good morning. Today we are going to talk about simple regression. What's meant by regression analysis? Regression analysis is concerned with the study of the dependence of one variable, which is the dependent variable, on one or more variables which are the independent or the explanatory variables, with a view to estimate the average value of the former in terms of the known values of the later. This means that we would like to study the impact of one variable or number of variables on another in order to identify or to determine the average value of the dependent variable given that the values of the independent variables. So once again, we would like to study the dependence of one variable, which is known as dependent variable, on one or more variables which are independent or explanatory variables. Explanatory means explains the variation in the dependent variable. If a variable x explains the variation in y. Okay? So this means that regression analysis means that we would like to study the relationship between two different variables. How to study the relationships? Economic studies mainly concerned with the study of the interrelation between the economic variables. So we would like to study the relationship among the different variables. Say, for example, there is a relationship between price and the quantity demanded. There is a relationship between income and the consumption. There is a relationship between interest rate and money supply, and so on. So most of economic relations are interrelated, and we would like to study the relationship among these relations. So in order to be able to develop and understand any relationship, we have to answer 5 main questions. Number 1, what are the variables? Okay, so we would like to study relationship between income and consumption. So these are the variables under consideration. Number 2, which variable needs to be explained? Or in other words, what is the dependent variable? And what are the explanatory variables? So if you are going to study the relationship between consumption and income, so which variable is the dependent and which is independent? In our example, consumption will be the dependent variable, or consumption is the variable which needs to be explained, and income is the explanatory or the dependent variable. Number 3, is the relationship is positive or negative? Number 4, how much will be the value of the dependent variable if the value of an independent variable is 0? And with respect to question number 5, by how much the dependent variable will change if an independent variable changes by a small amount or 1 unit? By how much the dependent variable will it change if an independent variable it changes by 1 unit? So these are the 5 main questions that should be answered in order to understand and develop the relationship between two variables. The best way in order to understand this relationship and to answer the questions is to put this relationship in a mathematical form. The commonly used mathematical form for any relation is that y equals alpha plus or minus beta x, where y is the dependent variable, x is the independent or the explanatory, positive or negative is the sign, which is the answer of question number 3. Alpha and beta are the parameters. So returning back to our example, as we said that with respect to question number 1, we have to identify or determine the variables. So our variables are y and x. Number 2 is to identify which variable is needed to be explained. So we said that y is the dependent variable and x is the independent one. Number 3, whether the relationship is positive or negative. This can be determined by the sign. With respect to question number 4, by how much will be the value of the dependent if the independent is 0? If x is 0, so y will be equivalent to alpha or the value of alpha. And finally, by how much the dependent variable will change if x change by 1 unit or very tiny change, which is the value of b or the slope. Okay, so this is the mathematical form of the equation or of the 5 main questions under consideration. Now we would like to know how to get the fitted regression line. Say, for example, we are going to study the relationship between income and demand. Do you think the relationship between income and the quant demanded is a positive or negative relationship? Actually, it is positive relationship, but it's not always the case, as in some cases, if income increase, demand is going to decrease, and this is the case of inferior goods. So in order to identify whether the relationship is gonna be positive or negative, we have to collect data. So once again, first we have identified that we would like to study the relationship between income and demand. Then we said that according to economic theory, there is a positive relationship between income and demand. But in some special cases, this relationship can be negative instead of positive. So we cannot determine whether it is positive or negative. As a result, step number 3, we are going to collect data. Here is an example for some collected data. This is QZ and income. This is quant demanded for different number of towns. Okay, so at a certain point of time, this is the number of units demanded in different towns. So as we are going to be concerned with number of towns at a specific point of time, so this is a cross-sectional data. Okay, so this is the number of units at different income levels. In order to understand the true relationship between the demand for pizza and the income, we have to plot a graph for this relationship. In order to identify whether it is a positive relationship or a negative one, we have to plot a graph. This is income on the x-axis and quantity demanded on the y-axis. It's 4, 8, 12, 16. Okay. It's 4, 8, 12, 16, and 20. 20, 40, 60, 80. Okay. So it's 5 and 27, 5 and 27, 10 and 46, 20 and 73, 8 and 40, 4 and 30, 6 and 28, 12 and 40 and 46, and finally 15 and 56. So if you are going to connect these points together, we cannot determine whether it is decreasing or increasing one. This is true relationship. This figure is known as without the line. Okay, it's just dots. It's known as a scatter diagram or a scatter plot. So from this scatter diagram, we cannot determine whether it is a positive relationship or a negative one. So now we have to convert the mathematical equation to an econometric one in order to be able to estimate the parameters and to find whether it's going to be positive or negative relationship. So returning back to our equation, as we said, y equals alpha plus beta x. This is the mathematical form. Now we would like to convert it to be an econometric one. So we are going to add one more term for this equation, which is the error term or the disturbance term. So we can write it as y equals alpha plus beta x plus u, where u stands for error term or disturbance term. Actually, this is for the whole population. What's meant by population or sample? If you are going to talk about quant demanded and income, as we said in our examples, that we are going to collect data for a number of towns. But if you are going to collect data for all towns in a country, this is going to be population, not sample. But actually, in real life, we cannot collect data for the whole population. So we are going to deal with sample and then generalize the results. So we would like to fit a straight line using sample data, not population data. So the relationship, this relationship will be converted to a true estimated relationship for a sample, not for the population. So this is related to population. If it's going to be related to a sample, it will be written as y equals a instead of alpha. So alpha is the parameter for the whole population, while a is for a sample of the population, plus b instead of beta, x plus e, where a and b are the estimated values of alpha and beta, and e is the residual or the estimated value of the error term. Residual equals in meaning the estimated value of the error term. Estimated means that they are estimated using sample, that we are going to use sample instead of population in order to find the value of A, B, and E. Now we are going to use the collected data in order to find the value of A, B, or to estimate the model. Later on, we are going to talk about how to estimate the model using numbers and equations, but for now, just would like to understand the steps. So Y will be estimated, or in other words, to find the fitted straight line based on a sample data. After estimation of the model, we can write it as y hat. Y hat means estimated value equals a hat plus b hat x. Now returning back to the the 5 questions. Already question 1 and 2 has been answered before. Now we are going to answer from question 3 to question 5. First, with respect to question number 3, which is whether the relationship is positive or negative. From this equation, we can identify that the relationship is a positive relationship. With respect to question number 4, what is the value of y if the independent variables equal 0? So if x equals 0, the value of y will be equivalent to a hat. So if a hat equals 5, so the value of y will be 5, and so on. With respect to question number 5, which is by how much y will change. If x changes by 1 unit, it will be by b hat. So if b hat equals 2, so if x increases by 1, y will increase as the sign is positive sign by 2. Okay, if we are going to use data described in the previous table and we are going to get the value of a and b, so we can write the equation as y hat equals 14.5 plus 2.9 x. So this means that with respect to question number 3, there is a positive relationship between income and quantity demanded. This means that the commodity is normal good. With respect to question number 4, if x equals 0, y equals 14.5, or actually y hat, which is the estimated value of the dependent variable. With respect to question number 5, if x increased by 1, then y hat will increase by 2.9 units. If income increase by £1, people are going to increase demand by 2.9 units. Now we can use this equation in order to find the estimated values of the quantity demanded of pizza. So we are going to substitute using the values of x to find y hat. When x equals 5, estimated quantity demanded of pizza will be 29.1. The actual value was 27, but the estimated one is 29.1. So they are not identical to each other, but they are close to each other. So the estimated value is not the actual one, but the best approximation for the actual value. If income is 10, quantity demanded will be 43.6. If it is 20, it's 72.7. Actually, in the actual data, if income is 20, quantity demanded is 73. In the estimated value, if income is 20, it's 72.7. Okay? If it is 4, 37.8, and so on. Now we can use these estimated values and draw a graph or draw a line on the same graph. Okay, here's our example. Okay, so this is the scatter diagram using the data, the actual data. Now we are going to plot the estimated one. The estimated data will be a straight line. Sorry. So this is the estimated line or the fitted line. This fitted line has an intercept of 14.5 and a slope of 2.9. Okay, it is the best fitted line. Okay, so this is known as best fitted line. So the dots represent the actual values and the line is the estimated one. The difference between the actual value and the estimated one, this is the error. So each one of them, this is the error. So this is why we add E to the equation, as we are not going to determine the actual value, but an average or best fitted line or best fitted value, not an actual one. This is the end of our lecture today. Thank you. See you next week.